Hello everyone, I'm Ryohei Suzuki from the University of Tokyo, Japan presenting. Today I'm going to talk about our new book, AnnoTone. Nowadays, recording videos, making video contents, and sharing them online have become one of the casual hobbies for every people, possibly including real children. And we have high definition and cheap video cameras, and computer hardware and software needed for video editing are available in a reasonable price in the market. And also, we have YouTube, Vimeo, Dailymotion, and other video sharing services working as a broadcasting platform for everyone. So, it seems that we have everything needed to enjoy creating video content and sharing them. But we know that video editing is still difficult in spite of them. What is the major challenges? Yes, it takes a lot of time to master the usage of video recording tools, and improvement on the user interfaces is demanded. But in this project, we focused on another problem that context-aware editing requires much labor for careful review and trial and error. In this talk, we define context-aware editing as any type of video editing process that intensively uses the context of recording, such as adding visual effects at appropriate timing, or clipping scenes based on the performance of the actors, or adding captions and overlays corresponding to the situation. Or sometimes we want to use some additional information which isn't shown directly on the video, like GPS information. Then, the objective of our project is to annotate videos with contextual information during recording to facilitate video editing for, first, to automate and speed up existing video editing activity, and to enhance video expressions by using some additional data. Then, in this talk, we propose a video annotation technique requiring no special equipment, and, a video editing workflow that exploits the embedded contextual information for efficient editing. And the core ideas of our work can be summarized as follows. First, we encode contextual information as inaudible sound signals, and we embed the encoded annotations directly into the audio track of video during recording. And finally, we extract the embedded information while editing the process in on-demand style. So, first, let me show how the user can use our system to annotate videos. Firstly, the user should attach a smartphone directly to a video camera, like these pictures and like that. Then launch the annotation embedding applications on the phone. And during a video recording, the smartphone gathers annotation information from either user input or sensors installed on it. The phone converts the annotation into a sequence of inaudible audio signals and transmits it from its loudspeaker. Then the video camera records the scene with superimposed audio watermarks. Then let me tell you the editing workflow with the embedded annotations. The overview of the workflow is as follows. First, the user imports recorded footages into their PC and loads them into a video authoring software. Then, the authoring software uses a watermark extractor to obtain the embedded annotation data, then uses the data to facilitate the editing process. Finally, the user gets the edited video and the audio track without annotation signals, and by combining them, our video content is completed. Then, let me go into the editing process in detail. In general, video editing activity involves a line pipeline simple editing processes, starting from clipping or adding captions or animations or color correction and so on. And our annotated audio track can pass through the existing pipeline as ordinary one because it is merely an audio data. When one of the processes in the pipeline needs annotation data for editing, it can use the provided watermarking extraction API provided by us to extract annotation data from the annotated track. And when the annotations become needless after the process, their signals can be removed by applying an audio filter. Then the user can get a clean audio track to proceed to the following processes, such as audio mastering. Then let me show you some applications of AnnoTone. The first example introduces the concept of record time editing. In this application, the camera operator annotates a long footage with success or failure information of the actor's performance, instead of repeatedly stop and start recording when the actor makes a mistake. And after recording, the software automatically extracts only the successful parts of the footage, and by combining the parts, creates a complete video automatically. And it would be very useful for recordings, for example, lecture videos, which may involve a lot of mistakes by lecturer. And yes, using GPS receiver of a smartphone, we can exploit positional information for video editing. For recording, the smartphone periodically embeds the location data of the camera. Then user can get a sequence of locations or a path of a footage while editing. Now, such a sequence can be used to create an overlaid map like the left image, or in the right image, footage is mapped on a geographical map as a path, and the user can clip a portion of the footage by sketching a corresponding path on the map. This map-based clipping technique might be useful for dealing with a long video camera, long video with movement, such as a video of touring. And annotations can be used to create various kinds of overlay contents. In these applications, the camera operator annotates a video of chess game with the chess note using the notation interface shown in the left. Then the system automatically generates the overlaid graphics of the chessboard as a right move. And we also prepared a mechanism to integrate AnnoTone with Adobe After Effects software. Our plugin can provide annotation data to be used by the editing workflow of After Effects to generate, for example, various effects or animations. It enables users to exploit annotations with the established editing practice of After Effects. The way of integration is as follows. Firstly, the AnnoTone software analyzes the footage to extract annotations, and the system generates a text layer containing JSON formatted annotation data at each time frame. Then, the user can associate video effects, parameters, or animations with annotations using the expression function of After Effects. It is a lightweight end-user scripting mechanism. Then, let me talk about the technical detail of audio watermarking method of AnnoTone. It is known that humans' hearing sensitivity drops with the increase of sound frequency, and most humans cannot hear high-frequency tones above 70 or 18 kHz. On the other hand, ordinary video cameras with microphone can record high-frequency sound up to 22 kHz. Therefore, we can hide information in the high-frequency range of the audio track as modulated signals. This is an example spectrogram of an ordinary audio track of a video, and here is a high-frequency region, which is almost inaudible to human. And we hide information as this. So, what is the benefit of using the audio watermarking technique for data hiding? First of all, it is compatible with almost all video cameras because it only requires microphones for embedding. And secondly, the synchronization between annotations and the timestamp of video can be preserved throughout the editing process, even if a clipping is applied, due to the direct embedding on the video sequence. And additionally, the watermark signals can be easily removed by applying low-pass filter. Then, watermarking protocol uses a dual tone multi-frequency or a DTMF to modulate digital data into audio signals. It represents information per unit signals by a combination of two single tones from 7 frequencies. And our packet representation have variable length payload and 400 bit per second gross data rate. Then, let me introduce some related work of AnnoTone. Context Cam is a special camera which can record contextual information such as location and person presence over home videos. It stores annotation in frames of video by image watermarking technique. Indeed, it realized context-aware video recording for a specific purpose. But because it is simply a special camera, this technique is not compatible with existing equipment, unlike AnnoTone. Krypton, or auto sound control protocol, is an interaction technique between loudspeakers and smartphones of audience at music venues, and it uses a high-frequency modulation to convey simple information. AnnoTone's audio watermarking technique is very similar to that of Krypton, and can be seen as an extension of that. But the purpose of it is very different. AnnoTone uses such high-frequency communication method for supporting video editing. So let me show you the result of performance evaluations briefly. Firstly, we measured the maximum data rate of watermarking, which can achieve enough reliability. And the result shows that almost 100% correct detection rate can be achieved with 400 bit per second annotation data rate for acoustic environments. There, silent room and public street, and with playing rock music and with electronic music. And next, we measured how long can watermark signals travel through air from a smartphone speaker. The result shows that they can travel up to about 20 centimeters, and it implies that user can use flexible hardware setup to some extent when it is difficult to directly attach a smartphone to the video camera due to the shapes of them. And for example, the user can use a 3D printed attachment of a smartphone to the video camera to use AnnoTone. And thirdly, we tested the durability of watermark signals against audio format conversion, a common process in video editing. And according to the results, watermarks can be preserved after being converted into various IC3 and AAC formats, and if enough bit rate is given. On the other hand, if we use MP3 as a destination format, we couldn't preserve watermarks even if the bitrate setting was very high. And finally, we tested the transparency or imperceptibility of audio watermark signals for human ear. And we hired 6 participants and gave them a task of clicking a button when they notice a noise while listening to an annotated audio track. The results showed that watermark signals are not completely transparent, and especially young participant was able to notice some of them. But they became almost completely transparent after applying low-pass filter. And we admit AnnoTone has some limitations. First of all, it requires one-off development of annotation embedding applications for smartphones for embedding different types of annotations. And secondly, the cause of audio quality loss in the process of watermark removal is inevitable because it simply uses low-pass filtering. And the data rate of annotation is significantly limited. Therefore, if we want to annotate a video with a large amount of data, we should consider another way. For example, we can use the AnnoTone's annotations as anchors for separately recorded body annotation data. Then, as a future work, we are considering about transmitting watermark signals from publicly installed speakers to annotate many videos simultaneously. It could be used to synchronize or integrate a large number of videos recorded at the same place, such as stadium, to create new types of video contents like multi-view videos. Also, similar technique could be used for entertainment use at amusement parks and so on. Okay. Then, let me conclude the presentation. We propose the video annotation technique using audio watermarking and video editing workflow, exploiting annotations. And the benefit of it is it can facilitate and enhance non-professional video editing process without special equipment. That's all. Thank you.
Are there any questions for our speaker? So please come up.
Hi, Tom Bartendale, Newcastle University. Very interesting work. Well done. So I've done some development in this myself. It's a shame you hadn't found the work because I'd gone through a lot of the problems with DTM data rates and recording metadata and things like that. But my question really is, the stuff we were doing didn't really explore the interface for inputting the metadata. Have you got any